All right, here's the second half of our notes for absolute value functions. We learned that absolute value functions look like a V, and our first step is to find where the vertex is and then just graph points from there from our table. So let's take a look at a few of these. I don't think we'll do quite all of them, but let's start with number 4. Okay, so we set what's inside of our absolute value equal to 0. 3x plus 2 equals 0. We set that equal to 0. That's our very first step. And then that's going to give us the x coordinate of our vertex. So we solve for x. We have 3x equals -2, divide by 3. And oh no, it's a fraction. All right, that's okay. We can do a fraction. That's the x coordinate of our vertex. Now you have a couple options here. You could do like -1, -2, -3, but what I like to do is I like to keep these as a fraction, and I like to step back and forward from that fraction. So from -2, to get more negative, we would go -3/3, -4/3, and -5/3. And to get more positive, we'd go -1/3, 0, and 1/3. So I just took the size steps that I took was 1/3. 1/3, 1/3, 1/3. That way the size steps that I'm taking each time are equal, and I can graph those points. They're going to be symmetrical. If you pick other numbers, it's fine. You can always graph from a table. If you plug this number in for x and get out a number for y, you can graph that point and connect it. So let's plug in our vertex, which is -2/3, and see what our y coordinate of our vertex is. Well, we have 3 times -2/3 plus 2. Well, that gives us -2 plus 2, which is 0. So our vertex is at -2/3, 0. Okay, so -2/3 is not quite -1. It's right about there. And then we plug in other points and see what we get. Now when we plug in -3/3, -3 times -3/3 plus 2, we have -3 plus 2, which gives us the absolute value of -1, which gives us 1. We can go on the other side. Should be the same thing. It is. When you take -1/3, multiply it by that, you get -1 plus 2 is 1, and the absolute value of 1 is 1. All right, -4/3, we plug it in here. 3 times -4/3 plus 2, those cancel out. You have -4 and +2, which equals -2. The absolute value of -2 is 2. And then let's do 3 times 5/3, -5/3. So that gives us -5 plus 2, which is -3. Absolute value of -3 is +3. Plug in 0. We get absolute value of 2, which is 2. You plug in 1/3, you get 1 plus 2, which is 3. All right, so we plotted our vertex, and now we can just plot the rest of our points. And honestly, I think I'm going to plot some of the ones that are easier, like -1/3 or 3/3 is really -1, -1 and 1, and then 0 and 2. Those ones are just easier to plot because they're whole numbers. But then we can go here to like -4/3, 2, -5/3, 3. There we go. All right. Again, let's look at our domain and range. Domain is going to be all real numbers. The range, we don't have any values down here, which means that all of our y's are greater than or equal to 0. So you might be asking yourself, are they always going to have a 0 coordinate? No. We could look at this one. We won't do this one in the notes. But if you look at this one and do it yourself, you'll find that it's actually shifted up. 1, 2, 3, 4, 5. This one looks like this. So your vertex for this one is actually at 0, 5, and then you can go from there and then your domain for this one would be all real numbers, but your range would actually be y is greater than or equal to 5. So you can kind of fill that out on your own. All right. Now let's take a look at this one right here. So our vertex, x plus 1 equals 0. So our vertex, the x-coordinate of our vertex is -1. When we plug that back into here, I have -1 plus 1 is 0. The absolute value of that is 0. And -0 is still 0. So my vertex is at -1, 0. Okay. We're going to pick points bigger and smaller and bigger. So when I plug 0 into here, I get 1. The absolute value of 1 is 1. But then I have this negative. So that actually becomes a -1. Okay, so let's take a look at that. When I plug negative absolute value of 0 plus 1, that's absolute value of 1, which is 1. And then I have negative times that, which is -1. Let's plug in 1 to this. 1 plus 1 is 2. The absolute value of 2 is 2. And then that's negative, so -2. 2 plus 1 is 3. That's a -3. And then if we do the same thing on this side, -2 plus 1 is -1. The absolute value of -1 is +1. And then we multiply this by a negative. So we get another -1. Again, this is just plugging in x and getting out your y. That's -2. That's -3. So then we can just plot our points. That would be at 0, -1, and -2, -1. Are you seeing a pattern here? This one actually opens down. And that's because that negative sign in front of it, that's what changes that. We'll learn about that in vertex form. But there's that one. And then basically we have to figure out domain and range. Well, we know domain for all of ours is going to be all real numbers. Well, so the range, we have y values. We don't have any y values up here. There's not a single point on our graph that goes up here. There's not a single point on our graph that has any of these numbers as its y value. But starting at 0, we have points on our graph forever and ever and ever. So for this one, y is less than or equal to 0. For every number less than or equal to 0, we have at least one point on our graph that has that y value. All right, let's take a look at this one. Again, to find our vertex, we set what's inside of the absolute value equal to 0, and we solve for x. Subtract 1. So we have 1/2 x equals -1. Multiply by the reciprocal on both sides. We have x equals -2. So that's our x coordinate of our vertex. When we plug that in here, we'll get our y coordinate of our vertex. So we'll say 1/2 times -2 plus 1 minus 4. Well, that gives us -2, or -1, excuse me. That gives us -1 plus 1, which is 0. Absolute value of 0 is still 0. And then minus 4, so -4. So our vertex is at 1, 2, 1, 2, 3, 4. Okay, we just plug in points, -3, -4, -5, -1, 0, and 1. When we plug in -3 to this one, it's going to be -3/2 plus 1, absolute value of that, minus 4. All right, let's take a look at that. 1/2 times -3 plus 1, absolute value, minus 4. Okay, so that's -3/2 plus 1 minus 4. -3/2 plus 1 gives us -1/2. Absolute value of that is +1/2. So 1/2 minus 4 gives us -3.5. Right, because you have -4 minus 1/2 basically. -4 plus a +1/2, which gives us -3/2. 3.5. Okay? When we plug 4 into this, we get -4 divided by 2 is -2 plus 1 is -1. 1 minus 4 is -3. And then see the pattern. This one's -2.5. This one's negative 3.5, negative 3, and negative 2.5. So we're just going to graph this, and I'm just going to graph the even ones. It makes it easier. 1, 4. There you go. There's the graph for that one. All right, let's finally look at some piecewise functions with absolute value functions inside of them. Okay, so first we graph the functions and then decide what part we're going to keep and what part we're not going to keep. So this is just a line, y equals negative 2x plus 1. Well, you know how to graph that. That has an intercept of 1 and a slope of negative 2. Down 2 over 1, down 2 over 1. So let's just graph that. Okay, there's that line. And this says if x is less than 4, we want this function. So if x is less than 4, we want to keep this function. So I go to x equals 4. 1, 2, 3, 4. And I'm going to keep all of the function where x is less than 4. But not where x is equal to 4. That's an open circle there because it says I want to keep everything less than 4, but I don't want to keep equal to 4. And then I just erase the part of the function that I don't need now. All right, now let's graph the other function. This is an absolute value function. X minus 3, that's a 3. Okay, so we say x minus 3 is equal to 0. We add 3 to both sides, so our x-coordinate of our vertex is 3. And when we plug that back into our function, we have 3 minus 3, the absolute value of 3. Y equals 0. So our vertex is at 3, 0. Now if we plug in, let's see, if if x equals 4, that's 4 minus 1 is, or 4 minus 3, which is 1. Absolute value of 1 is still 1. Now if x is equal to 2, 2 minus 3 is negative 1. Absolute value of that is 1. Plug in 5. 5 minus 3 is 2. Plug in 1. 1 minus 3 is negative 2. Absolute value of that. All right, so I could graph this entire v, but I know I'm not going to need it, so I'm not going to graph that other side. Now again, we're going to say, this says, if x is greater than or equal to 4, I want to keep this function. So I go to x equals 4, and I'm going to keep the function for all values that I can see that are greater than or equal to 4. So I want to keep all of that, and then I want to get rid of all of this. And there is your piecewise function. It's not so bad, right? The domain of this, let's take a look. This goes forever and ever in this direction and forever and ever in that direction. And here at this, where it's discontinuous, right here where it's discontinuous, there is still 1 point, right? If I have my ruler here, I'm still touching 1 point on my graph. I'm touching right here on my graph. So our domain is all real numbers. And our range, well, I go forever and ever in this direction. But if I come down here, the lowest point that I will ever get to is 1, 2, 3, 4, 5. Let's see, it's actually negative 7. It's negative 7. So anything greater than negative 7, I have a point on my graph. But anything less than that, I don't have any points on my graph, right? I have no points on my graph down here, so my range is y is greater than negative 7. And I will leave this last one for you to do. If you need some help, come in and talk to me.